space and time. These two words hold within them the essence of our universe. These two fundamental concepts form the very fabric of our existence, weaving together the tapestry of reality as we know it. They are the grand stage upon which the cosmic drama unfolds, a stage that has been set for billions of years. Yet despite their omnipresence, they remain among the most profound mysteries in the universe, eluding our complete understanding. For millennia, philosophers and scientists have pondered the nature of space and time, seeking to unravel their secrets. Is space an empty void, or does it possess an inherent structure, a hidden framework that we have yet to fully comprehend? Is time a relentless river flowing ever forward, or can it be manipulated and distorted, bending to the will of the cosmos? These questions lie at the heart of our quest to comprehend the cosmos and our place within it, driving us to explore further and deeper. Join me on an extraordinary journey as we delve into the depths of space and time, venturing into realms both familiar and unknown. We will explore the revolutionary ideas of Albert Einstein, who shattered our classical notions of these fundamental concepts with his theories of relativity. Prepare to have your mind stretched and your perception of reality challenged as we navigate through the complexities of the universe. Our exploration will take us from the smallest particles, the building blocks of matter, to the largest structures in the universe, the vast galaxies and beyond. We will journey to the event horizon of a black hole, where time itself seems to stand still, and the laws of physics as we know them break down. Along the way, we will encounter mind-boggling concepts that will ignite our imaginations and deepen our appreciation for the elegance and grandeur of the cosmos, from the birth of stars and colorful nebulae to the solitary journey of astronauts floating in the vast expanse of space. We will trace the evolution of our understanding, from ancient star maps to modern space observatories, each step bringing us closer to the truth. We will witness the birth of the universe in the cataclysmic event known as the Big Bang, and follow its expansion over billions of years. We will delve into the strange world of quantum mechanics, where particles can exist in multiple states at once, and reality is far stranger than fiction. And we will ponder the possibility of a multiverse, a collection of parallel worlds that may exist alongside our own, each with its own version of space and time. Ultimately, our journey is not just about the cosmos, but about ourselves and our place in this vast, mysterious universe. It is a quest to understand not only the external world, but the inner workings of our own minds. So, let us embark on this journey together, as we unveil the mysteries of space and time, and seek to uncover the truths that lie beyond the horizon. We often perceive time as a linear progression, a straight line extending from the past, through the present, and into the future. This perception is deeply ingrained in our daily lives, from the ticking of a clock to the changing of seasons. But what if our perception of time is merely a limited glimpse of a much grander reality? What if time, as we know it, is just a small part of a more complex and intricate system? What if time is not a line but a dimension, just like the three dimensions of space? This idea challenges our conventional understanding and opens up a realm of possibilities. Imagine a vast, four-dimensional tapestry. This tapestry is not just a static image but a dynamic, ever-changing fabric that encompasses all of existence. This tapestry represents the fabric of space-time, where time is interwoven with the three dimensions of space: length, width, and height. Each thread in this fabric is a moment in time, intricately connected to the threads of space. Every point on this tapestry represents a specific event in space-time. These events are not isolated, but are part of a continuous and interconnected web. Time, as the fourth dimension, is not static. It flows and evolves, much like a river carving its path through the landscape. It is dynamic and ever-expanding. As the universe grows, so too does the dimension of time, stretching and bending in ways we are only beginning to understand. As the universe expands, so too does the dimension of time. This expansion is not just a physical phenomenon, but a temporal one as well, affecting everything from the smallest particles to the largest galaxies. Every moment that passes adds another thread to the cosmic tapestry, weaving a rich and intricate history of the universe. Each thread tells a story, a narrative of events that have shaped the cosmos. But time is not merely an abstract concept. It is a tangible force that influences the very fabric of reality. It is an integral aspect of the universe that governs the motion of celestial objects, the interactions of particles, and the very process of aging itself. Time dictates the rhythm of the cosmos, from the orbits of planets to the life cycles of stars. From the birth of stars to the formation of galaxies, time orchestrates the grand symphony of the cosmos. It is the silent conductor, guiding the dance of the universe, ensuring that every element plays its part in the grand design. For centuries, the prevailing view of space was that it was an empty void, a vast and unchanging stage upon which the celestial objects played out their roles. The stars, planets, and other celestial bodies were thought to move through this static backdrop, governed by the laws of motion and gravity, as described by Isaac Newton. However, in the early 20th century, Albert Einstein revolutionized our understanding of space with his groundbreaking theory of general relativity. This theory fundamentally changed the way we perceive the universe and our place within it. Einstein proposed that space is not an empty void but rather a dynamic entity, a fabric that can be warped and curved by the presence of mass and energy. This concept was a radical departure from the Newtonian view and opened up new possibilities for understanding the cosmos. Imagine a bowling ball placed on a trampoline. The bowling ball represents a massive object, such as a star or a planet, and the trampoline represents the fabric of space-time. As the bowling ball sits on the trampoline, it causes the fabric to sag and curve around it. Just as the bowling ball causes the trampoline to sag, massive objects create distortions in the fabric of space-time. These distortions are not just theoretical constructs. They have real, observable effects on the motion of objects and the behavior of light. These distortions are what we perceive as gravity. Gravity is not a force acting at a distance, as Isaac Newton had proposed, but rather a consequence of the curvature of space-time. Objects move along the curves and dips in this fabric, following paths determined by the warping of space-time. The more massive an object, the greater its gravitational pull, and the more it warps the fabric of space-time. This warping can become so extreme that it creates phenomena such as black holes, where the curvature of space-time becomes infinite and not even light can escape. This warping of space-time affects not only the motion of objects but also the passage of time itself. Near massive objects, time slows down, a phenomenon known as time dilation. This effect has been confirmed by experiments and observations, further validating Einstein's theory of general relativity. The fabric of reality, as we now understand it, is a dynamic and ever-changing tapestry, woven by the threads of mass and energy. Section 4. Einstein's Revolution, Unifying Space and Time. Before Einstein, space and time were considered separate and distinct entities. Time flowed at a constant rate, unaffected by the events occurring within space. However, Einstein's theory of relativity shattered this classical view, revealing a profound and interconnected relationship between space and time. Einstein proposed that space and time are not separate entities, but rather two sides of the same coin, inextricably linked to form a unified fabric known as space-time. This revolutionary concept forever changed our understanding of the universe and our place within it. Imagine a cosmic dance floor where space and time are partners, moving and swaying in perfect harmony. The presence of mass and energy influences the rhythm and flow of this dance, causing space-time to warp and curve. This warping of space-time affects not only the motion of objects, but also the passage of time itself. Einstein's theory of relativity revealed that time is not absolute but rather relative, meaning that it can flow at different rates depending on the relative motion and gravitational pull experienced by observers. Section 5. Dancing with Time, How Speed and Gravity Shape Our Reality. One of the most mind-boggling consequences of Einstein's theory of relativity is the idea that time is not absolute, but rather relative. Time can flow at different rates depending on two main factors, speed and gravity. Imagine two identical clocks, one stationed on Earth, and the other traveling at a significant fraction of the speed of light. According to Einstein's theory of special relativity, the clock in motion will tick slower than the stationary clock. This phenomenon is known as time dilation. Time dilation occurs because the faster an object moves through space, the slower it moves through time. As an object approaches the speed of light, its motion through time slows to a crawl. Gravity also affects the flow of time. According to Einstein's theory of general relativity, time slows down in stronger gravitational fields. This means that time passes slightly slower at sea level than it does on a mountaintop, where the gravitational pull is weaker.